One of our main huge problems we have in the lab is when I'm trying to teach new guys how to mix refractory, Thermbond always comes up. And they notice we have different charts for the different series of activator. The reason for that is because, as you can see, that it has a different specific gravity, which means it's different than water weight, right? So it actually weighs more than water does. So water weighs 8.34 pounds per gallon. And the activator, the Activator Series, weighs 11.2 pounds per gallon. So what that means is if you're creating a ratio, you're trying to figure out your percentages, your milliliters or whatever, and you're using this, you're going to over liquefy the sample by a lot. And let's just say, for instance, if you use a 12L and you're batching out 15 pounds of material and it's at 7.6% like they recommend, using water weight, that's going to end up being 516.8 milliliters of water. And it's, in reality, it's really only 384.6 by using the 11.2, which means you're over liquefying your sample by 132.2 milliliters, which is why you have constant failure with 12L production samples, is because there's too much activator in it. I understand, it's got a long way to go. It sets pretty quick, which 12L does. It's pretty good working time. It's a 2-minute mix, which is a lot longer than most of the Thermbond products. When you're trying to cast a gun grade, it's like 45 seconds or until the dries off the bottom. I'm just quoting their procedure manual. But 12L, it has a little bit longer of a working time, and you'll get a longer working time if you chill that activator down to as cold as possible, because it won't freeze. So you're mixing it, and you have different landings that has to go up. In the field, mixing is different than lab mixing. I understand that. And you're going to want to put a little bit more activator there, so that way it's pliable when it gets to the hole. Do whatever you want in that hole. My job is to teach you how to make the sample correctly. So don't over liquefy the sample, and everything's going to be fine. But we'll show you how we came up with these numbers. We're going to take some beakers over to the scale, and we're going to do it by weight. Right, so they say by volume, by weight. We can do both. It's not really a big deal for us. Now, if you're mixing one bag to one jug, that's probably a pretty good ratio. You're probably pretty safe. But if you're making a small batch, for, say, like making samples, you don't need more than 15 pounds. 15 pounds is the perfect amount to make a set of 321 sample molds for a Thermbond 12L. But just keep that in mind. I can't stress that enough. Put whatever you want in the hole. That ain't got nothing to do with me. Make the damn sample correctly, because I hate giving out bad test results. And I hate having to take phone calls all day long because people don't know what they're doing. This is just me trying to help you. I hope you appreciate it. All right, so just to follow up and elaborate a little bit on how I got my water weights versus the activator weights per gallon, we're gonna demonstrate that right now. So you see the scale just lit up. We're gonna pour the amount of milliliters that we need to make a gallon. This scale should say 8.34. So go ahead and Corbin, go ahead and get started. We'll see exactly how much that's going to be. I'll try to help it out, because this is going to take forever. Here's some more. Here's some more. Here's some more. All right, we're dumping it in there. Come on. 8 point. Whoa, we went over a little bit. Must have had a little bit more than what we needed. Coming out of those these are not as accurate as they need to be. You're seeing how they're, I don't know, it's kind of, anyway, you can kind of get the idea of what I'm talking about as far as the water weight goes. Now we're going to do it with the activator. All right, here we go with Thermbond. I had to put a piece of plywood underneath the cylinders in case it didn't get spilled. I don't want that shit to eat my cabinets. I don't think it will, but you never know. Stranger things have happened in here. All right, finishing up here. This should be the last of it. Yeah. Okay, now that we got that safety issue out of the way, we can get back to work. Okay. Here we go. Let me move myself over here. There we go. Well, you can see what's going on. All right, so this should come out to be 11.2 with the same amount of milliliters, and it's not going to be 834. So it'll be about 11.2, 11.3. All right, well, so same amount of milliliters, which was 3,785 milliliters. And it shows you that the activator is a lot heavier than the water is. So don't over liquefy. Use that 11.2 or 11.3 in place of your 8.34, and your calculations will always come out exactly like they should, you know, depending on what Thermbond you're using. All right, we just finished building this vacuum system that Tom's gonna go ahead and cut it on. Let's see how it works. We have sand everywhere all the time with a silicon carbide. So there it is over there. You barely hear that thing. It's a 4-inch hose. Uh-oh. Let me see how good it works. Oh yeah. You want to back up a little bit? Back up a little bit?
Back up?
Yeah, just like move it out of the way. Alright, so get all that silicon carbide sand out of there. See, there's more. Okay, go ahead. Yeah. There it goes. Might be easier to see it getting it over here. Oh yeah. That works a whole lot better. So it's all one system. It's all piped in, 4 inches all the way through underneath this system here. That's a better view. That way we can get all of the acrylic from the molds that we make sucked up right into here in this box. It's like a little suction box, but you can see pipe goes underneath there. All right. My ass in here. So right over there in the corner, a little plastic valve. It's called a blast gate. And every tool that we have hooked up to the system has its own blast gate. That way you can cut off the tools that you don't need, and you can cut on the exact tool that you need and get the full power of the system to that tool. So this goes all the way down to 1 micron on the filter, and then the cyclone separates all the heavy stuff from the smaller, and all the small fine dust goes into this little homemade bucket right there. We'll also have something very similar on our mixing station, just a lot smaller, not even a system, nowhere near as cool as that one. But this is a vent where we batch out our bags. You can see we got a little 2-inch pipe going there, little power switch. Get around all this. You can see the pipes, there they are right there. Going through, teeing up, just go there, and they come over to this mixer, where we have 2 of them around the bowl. And when the bowl's mixing, it'll swirl all that dust, gets sucked up into the system, and we don't have to breathe it. So it's just another one of the projects that we're doing around here, like this little deal here. We made this whole vent just for this, just to make things a lot easier, a lot safer, a lot nicer than just a regular old warehouse. We're breathing in dust all day long, walking around in dust. I mean, look, we try to keep it pretty clean in here. That's all oil stains and whatnot from the previous people. We try to keep it clean, and with this dust collection system here, it's going to make it a lot easier for us.